So the last thing we're looking at is domain of a function. So domain means what? We talked about this yesterday. Domain is focusing on the x. So I'm trying to break this down for you real easy. The domain of the function is what we call the largest set of real numbers for which the value of f of x turns out as a real number. So we want to exclude the following values from domain. When we look at a problem, if there's a denominator, what do we know the denominator cannot ever equal? 0. So if you look at a problem and you see a denominator, the first restriction we're going to have on our domain is the denominator cannot equal 0. So if you look at a problem, like this example here, to figure out what your domain is, you're going to have to say x minus 3 can't equal 0, which means x can't equal 3. And I'm trying to remember how they write this out in your book. Because there's like 3 ways I could write this right now. So this is how the book's going to write it. New notation today. This is what you're going to see.
Is it on this?
No.
Oh.
So look at this. Look up here. Shh. This is how they're going to write this. Let me explain what this means. That line in math we read as such that. So this right now says your domain is all x values such that x cannot equal 3. So that just says all numbers except for x can't equal 3. It's just a really mathy way of writing that. Okay? So one restriction on your domain, one thing you have to exclude from your domain is if there's a value that makes the denominator 0. Okay? Second thing we have to exclude is what happens with a radical. What kind of number cannot go under a radical? What is your restriction for when you put numbers under a radical? If you want a real answer, remember our focus is on real answers. What number can you not put under? You cannot have a negative number under the radical. So to say that, we have to phrase that in a way that would make mathematical sense. How do you say something is not negative? It has to be positive. So we need to mathematically say something is positive. How do I mathematically say something is positive? Greater than or equal to 0. So when you have a radical, the rule with a radical is your radical has to be greater than or equal to 0. So whatever's under the radical. I'm going to put under radical is going to be greater than or equal to 0. So that part under the radical, x plus 5, has to come out greater than or equal to 0. And then you have to, the same thing we did here where we solved it. We said the denominator couldn't be 0. We solved it to figure out what value that is. We're going to solve this too. So you're going to subtract 5 and you're going to get x is greater than or equal to negative 5. So then the domain is all x's such that x is greater than or equal to negative 5. That's how we're going to write that out. So the key things on this page that I'm going to go back and highlight right now is this one. Oh, this does not highlight well. I'm not going to highlight it that way. I'm just going to put a box around it.
What's that little line?
That means such that. It's just our weird notation. This is the weird math notation that I just kind of want to expose you to a little bit. This means all x values. The domain is all x values such that x is greater than or equal to negative 5. So these two things are the important things to look at. If you look at a problem and you see a denominator, you know you have a restriction on your domain. If you look at a problem and you see that there's a radical, you know you have a restriction on the domain. You just have to locate it by setting up the equation correctly. Notice you have different things you have to set up. If it's a denominator, we just say that it can't equal 0. If it's a radical, we have to say that that's bigger than or equal to 0 because we have to maintain that it's a positive number. We don't want it to be a negative number. Alright, so when we look at the first function, are there any denominators? This is kind of my thought process. Whoops. Do we have any denominators? Nope. Do we have any radicals? Nope. So then there are no restrictions, which means your domain what you can plug into that function, you can plug in any number you want, and you're going to get an answer. That means all real numbers, and we're going to write that as an interval. So that means our domain is from negative infinity up to positive infinity. That's your answer for the first one. So we are going to write these as intervals now that I looked at your book. So looking at number 2. Do we have any denominators? What should I probably do to that denominator first? Can we factor it? If it looks like something that can be factored, I would factor it first, because that's going to help you to find your restrictions. How many restrictions am I going to have here? 2, because there's 2 things in the denominator now, yes? And there was x squared in the denominator. The x squared tells me there's going to be 2. You could have technically set it equal to 0 and taken the square root, but when you take the square root, what do you have to remember? Plus or minus, you would still get 2. So your restrictions here are x minus 7 can't equal 0, and x plus 7 can't equal 0. So that means x can't equal 7, and x can't equal negative 7. So to write out the interval, we have to write intervals that skip those values. So if we started all the way on the left-hand side, because that's where we want to start, we would go, and actually if you draw a little graph here, it kind of helps me visualize it. We want to write intervals that skip these values. We can't have those values. So it's going to be from negative infinity up to negative 7, not including 7, so we're going to use the parenthesis. And then from negative 7, put an or in there, from negative 7 up to 7, or from 7 on to infinity. That's how you're going to write that answer out. You're literally writing intervals that skip those 2 values. So we have to break the interval at negative 7 and split it into separate intervals, and at positive 7 we have to break it too, so we skip that value. If you have a hard time with it, draw the picture, because I think the picture shows you that there's 3 sections, doesn't it? When I drew the picture, I had to name each section skipping over those values. How about the last one? We have a radical. So this one, because we had a denominator, the denominator can't equal 0. This one we have a radical. What did we say about the radical? What's the restriction on a radical? What kind of number do we want to be able to plug into the radical? Or get out of the radical, really? We want it to be positive, so the radical has to be greater than or equal to 0. So that part underneath, it's just the part underneath, don't keep the radical. We want to ensure that the part underneath the radical stays positive. So 9x minus 27 has to be greater than or equal to 0. Does that make sense to everybody? So then we get 9x is greater than or equal to 27. X is greater than or equal to 3. And again, it might benefit you to kind of think about that graphically. Whenever I do intervals, my brain works a lot better if I think about what that looks like. What does x greater than or equal to 3 look like? Parenthesis or bracket?
Bracket.
And which way am I shading?
Right.
To the right. So the interval is going to be from 3 on to infinity. 3 gets a bracket, infinity or always gets a parenthesis. It's been a little bit since we've done intervals. Does that make sense? So the 2 things you're looking for is denominators and radicals. If it has a denominator, that's a restriction. If it has a radical, that's a restriction. If it doesn't have either, you don't have any restrictions. We good?